So how do I use differentiation to actually go ahead and find the gradient of a curve? And I have this curve over here, y equals x squared, and they tell me to find the gradient of this curve when x is equal to 3. So how do I use differentiation to actually find out what the gradient will be when x equals 3, which is this point right over here? Let's try and do that. So the first thing I know is that differentiation, basically, we use the notation d when we're dealing with differentiation. So in a normal coordinate geometry class, I would have said, what is my change of y with respect to change in x? This time what I'm asking is, what is my change in y when my x changes by some amount? So instead of using this thing, which is what coordinate geometry does, I'm now using this thing, which is what differentiation does. And I'm going to show you guys how this thing works. So I'm going to erase this, and I have this equation for the curve, y equals x squared. So now I'm going to differentiate this. I'm going to say, how does my y change when my x changes, which in other words is what the gradient means. It means how much does your y change when your x changes. So what I'm going to do is I'm going to say, how does my y change when my x changes? And I'm going to do that on this side of the equation as well. So you have to do it on both sides of the equation. You can't do it on one side. So let's do that. So how does this thing change when my x changes? So what this is going to simplify to is this thing is just going to become dy by dx. And then what do I do with all of this? What do I do with all of this? So this is what you actually have to differentiate. This is where the actual differentiation comes in. And what you do in differentiation, whenever you're differentiating something, okay, whatever you may have in here, and it's x to some power n, then what the answer is going to be, what the differentiation is going to be, is basically it's going to be n multiplied by x, and x is now going to have a new power. The new power is going to be n minus 1. So let's apply this thing. Let's apply this rule. This is called the power rule. This is called the power rule. Let's apply this power rule to our differentiation over here and see what we get. So let's do that. So we have x to the power 2, and so our differentiation is basically going to be 2 times x, and I'm representing this x with a dot over here, because if I write a cross sign, then it's going to be confused with this x symbol over here. So x multiplied by 2, and then x is going to have a new power, which is going to be 2 minus 1. And so my answer is just going to be 2x raised to the power 1. This is my answer. And so now I know that my dy by dx is just equal to 2x. This is what your gradient equation is for this curve. And this may be weird to you guys. You may be like, well, why do I have an equation for my gradient? Why don't I just have a single value for gradient? Well, that's because in differentiation, you get an equation. And this equation, this gradient equation that you just found, this equation can tell you the gradient at any point of the curve. So if you go back to the graph over here, they were asking for the gradient when x is equal to 3. But you can actually, using your equation that you found, you can find the gradient at any point, not just x equals 3. So I can find the gradient at x equals 0. I can find the gradient at x equals minus 1. I can find the gradient at x equals pi. I can find gradient at x equals 1 by 3000. So any number, you can have any number. You can use the equation to find the gradient of the curve at that point. In this problem, they basically wanted the gradient when x was equal to 3, which was this point right over here. So let's see, using our equation, what the gradient is going to be. So all we have to do is we go back to our equation. And what we do is, instead of x, we just put the coordinate 3. And so the gradient is just going to be 6. So again, don't forget this thing, this d's, don't let this d and this d confuse you. This fraction just represents what the gradient is. And at 3, when x equals 3, the gradient of the curve is 6. And I want you guys to go ahead and find out the gradient at all of these points. So go ahead and find out what the gradient will be at all of these points.